All right, hello, folks. Our next speaker is Michael Roytman. So Michael is a software engineer at 2U edX. In his 6 years at the company, Michael has worked on a variety of applications and features, including proctoring, program console, insights, and LTI. And today he's here presenting Unlocking LTI, how we decoupled LTI 1.3 launch from the Open edX platform. Everyone, please welcome Michael.
Hi, everyone. Can you hear me? Okay. So as Dave said, welcome to Unlocking LTI. Today we'll be talking about decoupled LTI 1.3 launches. We're going to cover what that even means, why it's important, and how you can do an LTI launch from your application. The reason I'm here today is that I feel that LTI has garnered a lot more attention in the last year or so, at least at 2U. So the objective of this talk is to make you more familiar with the state of our LTI implementation and the vision for the library overall. If you went to David Joy's talk yesterday, you may have caught him referring to LTI specifications as not fit for human consumption. And it's for that reason that I'm not going to spend any time reviewing LTI code in the repository. I just don't think that's a good use of our time. It would take hours. Instead, I've structured today's talk using diagrams as a sort of visual exploration of how LTI was implemented, the issues we encountered using it, how we address those issues in a way that we think benefits the platform. So this is an agenda for today. I've structured the talk as a series of questions because I think these are some of the questions you might have coming in here today just based on the title of the talk alone or the description of the talk. Going to spend around 35 minutes walking through this and then 10 minutes at the end for questions. So let's start with the first question, what is LTI? I know many of you are probably familiar with LTI, that's why you're here, but in case you're not, it's really important that you understand what LTI is, what it's useful for, and generally speaking, how it works. So let's start with a review of LTI. LTI is an acronym and stands for Learning Tools Interoperability. Unlike a lot of technology names, it does actually tell you quite a bit about how it works and what it is. It's a standard that describes how learning platforms like edX can seamlessly integrate with learning tools. And this integration is done through a browser-based LTI launch where a learner is launched from the platform to the tool. So an example of this might be a learner going to their Coding 101 course in the edX platform and being launched directly into, say, Jupyter Notebook directly from within the courseware. And in this way, LTI can greatly enrich the platform's content offerings. And it allows you to avoid bespoke integrations, avoid building custom features in-house. It's really powerful in that way. LTI as a standard is authored by 1EdTech, that's the authoring body, and has authored a number of LTI standards, including 1.1 and 1.3. There is a 1.2, but we don't really talk about it very much. And for the purposes of today's discussion, we're going to be just discussing the basic LTI 1.3 launch. That's just the launch. It doesn't involve LTI Advantage Services, if you know what that means, and it doesn't involve LTI 1.1. You can already do a decoupled LTI 1.1 launch. You can talk to me later about that if you're curious. So now that we understand what LTI actually is and what it's useful for, let's take a look at how it actually works. Long before a browser-based launch ever occurs, there's an integration step between a platform and a tool. And the integration step involves the exchange of configuration data, and the scope of that configuration data is defined by the standard, but it includes things like a client ID for the tool, a public key for the tool, the various URLs that or for the endpoints that implement the launch flow. But the way that this data is exchanged is beyond the scope of the standard, and every platform and tool will do it a little differently. On the edX platform, this is done by a course author. And the course author goes into LTI platform, that's edX, and more specifically Studio, and in the tool manually exchanges the configuration data. In Studio, they create an LTI component to do this. But this is the first step of the LTI integration. After this is accomplished, we can actually do the browser-based launch. We're going to do like a quick abridged view of the launch. I've removed a lot of detail from this. It's just the overall structure. So first, the key players are obviously the browser. Then there's the tool and the platform. And no browser-based launch makes a lot of sense without a learner. So we've got the learner here who wants to go to Coding 101 and go to Jupyter Notebooks. So they go to the platform and they encounter a LTI launch link, which they click. And this results in a request in the browser. And the request goes from the platform to the tool via the browser. And this is called the third-party initiated login URL. And the purpose of this is for the platform to inform the tool that an LTI launch is beginning, and also prompts the tool to make the subsequent request. The subsequent request is called the authentication response, and that's because the tool is asking the platform to authenticate the learner. The platform is acting as the authorization server. The reason for this is that it avoids the need for a learner to maintain a separate set of credentials for each LTI tool on the platform, and instead gives them more of an SSO-like experience. So by virtue of being authenticated with edX, they get access to their tool accounts. In response to the authentication request, there is the authentication response. This is also the LTI launch. It contains the LTI launch message, which contains all of what we call the contextual data about a launch, things like user's email address or other PII, the user identifier, roles of the user on the platform, the context in which the launch is occurring, like a course name, etc. This is all transmitted back to the tool in a JSON web token. Finally, the tool receives the LTI launch message and then issues a redirect in the browser back to the content. And then the content is rendered in the platform. There are a lot of boxes and arrows and lines here, but the most important thing to take away are the following key points that we should take with us through the rest of the talk. The first is that configuration data has to be exchanged between the platform and the tool at a band long before a launch. The LTI launch occurs in the browser through sort of two legs of the LTI launch, these sort of request-response cycles. And lastly, a platform has to send contextual data to the tool in order to give the launch context and color so the tool knows what to do and what is being launched to. So that's a quick overview of LTI, why it's important, how it works. And if I'm telling you that LTI is such a powerful extensibility mechanism, what is the problem? In order to understand our problem with LTI, you have to sort of use your imagination and pretend it's March 30th, 2022. You're on the Cosmonauts team at 2U, which is the team I'm a part of. You own proctoring. And your proctoring integrations are custom and bespoke. It's hard to add a third one. It's hard to maintain the two that exist. And you really want to use an LTI launch to a proctoring vendor in the courseware instead. But you quickly run into a problem, and we can take a look at that now. In order to understand the problem, we can take a look at how LTI is used on edX. I'm going to show a sample representation of a course tree as a tree to illustrate this. So we've got the course at the root, section, subsection, unit, component. I think we all know most of this, but this is important because LTI launches are done at the component level. An author goes into Studio, creates an LTI component, edits the configuration data in the XBlock that's stored in the module store, and then that's rendered in the courseware. Proctoring is done at the subsection level. It's a property of a subsection. So when a subsection is marked as proctored, that means that all of its descendants are a part of the proctored exam. And that means for proctoring purposes, LTI is not possible because it's done at the component level. And this brings us to the overall problem statement, and this applies to more than just proctoring, and that's that the implementation of LTI in the XBlock made it impossible to do an LTI 1.3 launch from outside the courseware. And this really limits the impact of LTI 1.3 beyond proctoring, and this is something we endeavored to solve. So we understand the problem, and that moves us really nicely into the approach. I'm going to walk through an overview of the architecture of our LTI implementation and describe what the strategy was for decoupling it before we go into the details in the fifth section. So, structure. We've got the platform, we've got the XBlock LTI consumer library installed into the platform, and this adds the LTI capabilities to the platform. In the library, we've got the LTI XBlock, which is the XBlock. It's called LTI consumer XBlock. And then all of the supporting code for LTI I've put into this LTI library rectangle. And looking at this diagram, you might be thinking, well, couldn't I just install XBlock LTI consumer and use the library and pretend the XBlock isn't there and everything works perfectly? Unfortunately, no. This is a more accurate representation of the relationship between the XBlock and the library. No clear boundaries, they sort of fused together. I mean, it makes sense, it was implemented this way. But it made it impossible to do an LTI 1.3 launch outside the XBlock runtime. But in order to enable the proctoring changes we wanted to make, we had to break them up. So we came up with this sort of aspirational diagram of what we wanted. We wanted a core LTI library that the XBlock depends on. There's no dependencies on the library to the XBlock. The library can be used in other contexts. This is aspirational, so we're not completely at this point, but we are a lot closer, and we're close enough to do a basic LTI 1.3 launch from anywhere. I also want to take this moment just to acknowledge that a lot of this work is built on OpenCraft's heavy investment in the repository long before we got involved or took ownership of the repository. They did a lot of work with LTI. The work I'm presenting today is only possible because of their work. So I just want to give that credit where it's due before we move on. So that was a look at our overall vision and approach for the library. But before we look at the details a little bit more closely, I want to take a moment to reflect on the impact of these changes. I'm sure you can appreciate this helps us a lot with proctoring, but it's also important to understand that this has impacts to the rest of the platform beyond proctoring. So here are a few ways that a decoupled LTI benefits the platform. First, LTI reuse. Here's the same course tree. I've added in these squares to represent the LTI integrations. Each LTI component has a one-to-one relationship with an LTI integration. Because LTI is implemented as an XBlock and the configuration data is edited through it and stored in the module store, each XBlock has its own LTI configuration, and this is a problem because course authors will often want to place a single LTI tool many times in the course. I mean, they might want to spread it throughout the entire course. That's really cumbersome to have to create a new LTI integration, not only in the platform, but also in the tool. And some tools really do not like when you do that and won't let you actually. So this has actually been our biggest point of feedback from course authors that have been willing to try LTI 1.3. It's just too much of a pain, and it really is an impediment to adoption on the platform. If you decouple LTI from the XBlock, you can do something a little bit more like this, where you don't store the LTI configuration in the module store, and you can then have a component, multiple components using the same integration. This makes authoring a lot simpler. It's something that we're currently investigating. That's possible because of the work that I'm talking about today. But this improvement is largely just a consequence of decoupling the two. It's not really a benefit we get from using LTI in more places. So we can take a look at some, I don't know, somewhat silly examples, but just to kind of get you thinking. This is my attempt at a representation of the studio course outline in the Learning 101 course. The important thing is the icon on the, is that your left? Right. Direction is hard. So the accessibility icon is just meant to represent an accessibility content scanning tool that could scan course content against a set of best practices, recommend alternatives. Having accessible course content is really important. We want equitable and impactful content, so this is a way to make course authoring easier and to result in more high quality content. On the LMS side, this is supposed to be the discussion forums. The icon on the right, the microphone, might be sort of an audio-based participation tool, maybe talk to text, or maybe you would read discussion posts out loud, or provide voice memo capabilities. Just one way to think about extending the platform through LTI to make participating in a course easier. The more generic scenario that I think has the biggest impact is just doing LTI from a Django app. This is just a sample representation of what this could look like, and this is the approach we have for our new edX exam service, which implements proctoring. We've got a micro front end that's going to render the LTI launch link to the user, communicates with a backend Django service that has installed the LTI library, and that generates the launch URL and also contains the views that implement request handling for the different parts of the LTI launch flow. So these are a few simple examples. The ones in LMS and Studio we may never do, but the fact that we can even consider doing them, I think, is a really big, exciting change. This wasn't possible a year ago. And And now the only limitation we really have is just the breadth of LTI tools in the marketplace. So I think that gives us an appreciation for the importance of the work. And I'm going to move on to how we did it in a second. So in this section, I'm just going to kind of go through section 3 under a microscope, essentially. I'm going to talk about the coupling points, how we solved them, and what that resulted in. So again, this is the edX platform. The LTI consumer library is installed into it. We have the XBlock, surprise, has handlers that implement the parts of the LTI launch flow, as well as the module store and the XBlock services. And the relationship between these components is something like this. Obviously, there's a relationship between the XBlock and the module store, and the XBlock services are used by the XBlock handlers to get important contextual data like learner PII can come from the XBlock user service, for example. Then we have a Django plugin, and the Django plugin was the first kind of rumblings of a decoupled LTI, the first attempt to put something in this library that could be used for multiple contexts. Of course, the plugin can be installed using the edX plugin architecture, but it also contains a set of views that implement request handling for the LTI launch flow, and we'll talk about the relationship in a moment. And then we also have, finally, the LTI configuration model that stores a small amount of configuration data. You might remember that I mentioned that configuration data is entered in the XBlock, and it's true that the majority of configuration data is stored in the module store, but a small amount is also stored in this model, mainly auto-generated stuff like a client ID for the tool or private key pair for the platform. But in order to get a full set of configuration data for an integration, you need to look at both. And the glue between them is this block property. The block property is a reference to a block descriptor for the corresponding XBlock. So the LTI configuration model's job is to consolidate its configuration data with that of the XBlock to return a set of configuration data. These are the main dependencies and relationships I want to mention. Before we move into some of the coupling points, we're going to walk through the coupling points and discuss them. But first, I just want to mention that we can think about the Django plugin and the LTI configuration as kind of parts of that core LTI library that are currently chained down, and we're going to see those chains in a second. Also, I'm going to be showing a lot of arrows, a lot of changing things. I've included a green star on the diagram just in case you get lost and don't know what I'm talking about. That's a way to sort of center yourself in the diagram. So first key coupling point is request handling. The Django plugin views, particularly the one that does the basic LTI 1.3 launch, doesn't do very much beyond calling the XBlock handler, and that in and of itself is sort of a coupling point that makes it impossible to run this plugin outside of the runtime. It just doesn't make any sense. There were other views in the plugin that implemented LTI Advantage that were more independent, that didn't rely on the handlers, but they still had a problem because they needed configuration data and contextual data, which they could not get anywhere else but from the platform. And that brings us to the second coupling point, which is configuration data. The plugin views accessed this XBlock reference, the block property, to grab configuration data from the XBlock. And then thirdly, contextual data came from Python APIs imported from the platform. And this was done through this compatibility module, which imported the Python APIs and then was used by the views. Obviously, this means that anywhere that these APIs don't exist, you cannot really run LTI or do an LTI 1.3 launch because you need this data. So as a summary, these are the 3 coupling points we worked on fixing. And if you overlay that rectangle again, you'll see that the direction of the arrows is going from this core library in the opposite direction that we want, to the XBlock, to the module store, to the Python APIs. So as a quick review, 3 key coupling points are request handling, configuration data, and contextual data. I'm going to walk through each one by one, the first being request handling. As a reminder, that's this relationship between the Django plugin views and the XBlock handlers. And in order for the Django plugin views to run outside of the runtime, they could no longer call the handlers. So what did we do about this? Well, we actually didn't do anything. OpenCraft was working in this repository before we got involved, and they were already in the process of doing this. They took the remaining XBlock handlers and rewrote them as Django plugin views. And that resulted in something a little bit more like this. The reason I still have an arrow is that some of the XBlock handlers actually now call Django plugin views to pass some data along, but some of the views are just completely isolated and are just installed into the application through the plugin architecture. But doing this comes at a cost. You're actually coupling even more to the Python APIs and the block property because you have more views in here that need contextual and configuration data, which leads us to configuration data. So the views need access to configuration data that describes the LTI integration, and they do this by reading from the block property. The problem here is that the module store is the source of truth for the vast majority of configuration data. So it's not really possible to run your plugin from anywhere that's not available or is too expensive to access. So our thought about this was, because we wanted to run the plugin in multiple contexts, what if the source of truth for the data could depend on the context in which the LTI launch is running in? What if we defined a small set of contexts that makes sense for the library to know places that it would know how to get configuration data from? And it turns out that the LTI configuration model already does this. It had a config store field that described a few key places where configuration data could be stored, and based on that knew where to go to get the configuration data. One of them was obviously config on XBlock, and that's what you're seeing on the screen here. It would know to use the block property to grab configuration data from the XBlock. What we did was add a third option called config on DB, which allows you to store the configuration data on this model. Of course, we added the fields, ran the migrations, etc. But now a Django app can store its configuration data on this model entirely without ever touching the block property or the XBlock itself. And that results in something a little bit like this. The arrow is still there because we're still using the block property, but it's now dotted to represent a more loose coupling because it depends on this variable. Lastly, we have the contextual data that the plugin needs. Again, this is this relationship. The compatibility module imports Python APIs from the platform. Obviously, if you're running somewhere where that doesn't exist, that's a problem. The problem, kind of like configuration data, is that the way a piece of contextual data is defined or accessed depends on the context the LTI launch is running in. And because we wanted this to run in a variety of contexts, we can't have the library be aware of dozens of ways to get contextual data. So instead of the plugin knowing where to get contextual data and pulling it from there, we inverted it and passed the contextual data from the installing application to the LTI library. But what is this contextual data exactly? I forgot to mention, there's this relationship that is now gone as a result of this change. So the contextual data is pretty simple. It's just a data class that has a variety of fields related to contextual data that comes from the specification. This is not an exhaustive list. But the idea is that an application can import this, get the contextual data from its context, instantiate it, and pass it to the application. And that gets passed around through the LTI launch flow. But there's a lot of sort of magic that's happening. It doesn't really make a lot of sense how that gets passed. How does it go through the two legs of the flow? In order to understand this, we have to revisit the LTI launch again. And I've cut off the rest of the launch because this is all that matters for these purposes. But this is the third-party initiated login request. The important part of the puzzle here is the LTI launch link. This, again, is a link to the third-party initiated login URL. When it's clicked, it kicks off the LTI launch in the browser. And there's a problem with LTI in the fact that there are two legs. In the first leg, in the third-party initiated login request, the platform knows what's going on. It has a lot of contextual information. It knows who that learner is, what tool they're launching, where they're launching from. In the second part of LTI, when the tool makes the authentication request, it's lost all of that. It doesn't necessarily know what course it's running. It doesn't know who the learner is. And the structure of the LTI launch link is a way that it can communicate that information back to itself. This is a sample LTI launch link. It has this LTI message hint query parameter. And the purpose of this is to pass a hint about the eventual LTI message. And what the platform can do is remind itself of the context that existed in the first leg, but in the second leg. And the reason this works is because the LTI standard requires that the tool receive this in the third-party initiated login request and then send it back in the authentication request completely unchanged. So the platform then receives it later. Our approach was to use this to pass a reference to the contextual data so that it would be received by the LTI library when generating the launch URL, and then received again by the views implementing the second leg of the LTI launch flow, and then the library would have access to this contextual data throughout the entire lifetime of the LTI launch. Again, a lot of magic there. So the way that this works, I'll show you in a moment. We still have this diagram. I'm going to add in 2 more pieces. We've got the views for the student view that renders the XBlock in the LMS, and then just for clarity, the Python API, and that's where that API function comes from to generate the launch URL. When a learner visits a component in the LMS, eventually the student view will handle the request. It'll collect contextual data from, I don't know, the XBlock services or the module store in this case, and instantiate an instance of the LTI 1.3 launch data class. They'll call the Python API passing this. Python API will generate a launch URL with a reference to the launch to the contextual data. That will be rendered in the browser, the request will be made, LTI will start. Eventually the second leg of LTI will, the tool will make the authentication request. That's the second part of the LTI launch flow. That'll be handled by the Django plugin view, which may or may not call the XBlock handler, but I didn't represent that here. And the reference is sent back, and that reference is the reference to the contextual data. Unless you stick the entire data class into the URL and encode it, there's a problem here. And we did try this, by the way. We tried to use a JOT and it didn't work. It was simply too long. But you need to maintain this data in the library between the first leg and the second leg. And we did this using a cache. This is short-lived data. LTI launches are short and ephemeral, so is the data. So when you, oops, sorry. When you generate the LTI launch URL, we also store that data in the cache and actually pass the cache key as the reference. And then upon receipt of the cache key, we pull it out of the cache. So the final state of the diagram looks more like this. And you can see that now this core LTI library doesn't have as many arrows pointing from it to the XBlock. And in fact, most of the arrows are pointing in the opposite direction, which is exactly what we want if we look at the aspirational diagram. Now, probably the most important part of this presentation is how you can do this. Fortunately, there are now 6 easy steps for doing an LTI launch from your application. We're going to take a look at those in diagram form. So this is your Django app. I'm assuming you have a micro front end, but if you don't, that's fine. Just will be a little different. You might have some views, maybe your backend for front end endpoint that returns the LTI launch URL to you. And then you're going to need some way to get contextual information. Let's just say you have some Python APIs here. The first step is to install the library into your Django app. You're going to install a lot more in here than just this. You will get the XBlock, but I don't have space for it. The second step is actually to store your configuration data in the model, either manually, that's what we're doing with proctoring because we only have one integration plan so far, or programmatically. Then from your backend for front-end view, whatever's generating the launch URL, you'll import the data class, get your contextual data, instantiate the data class, and then pass that to the Python API function to generate your launch URL. And you can do whatever you want with this launch URL. You can just issue a redirect from this point. You can send it back to the micro front end. It can just show a link. It can do an auto-submitting form, whatever. What's most important is that the request occurs in the browser. So here is a quick review. In the interest of time, I'm going to move on, but I wanted to end, after showing you this, with some next steps, some ways you can get involved if you're interested. So here's the same diagram. We would love to get rid of this line to remove LTI configuration data from the module store and this dependency on the XBlock and get something a little bit more like this. I also mentioned that LTI Advantage services have not been fully decoupled. So if I were to represent LTI Advantage services at this point, there'd be arrows all over the place. It's pretty messy, so we'd love to kind of decouple them and have a fully functional LTI 1.3, LTI Advantage implementation that can be done outside of the courseware. If we do this, we can consider kind of breaking these apart, having a separate XBlock and then the LTI consumer library that it uses, and eventually just completely pull it out, make it a lot easier to use across the platform. There's no need to install an XBlock if you have no use for it. This is what we would like to get to in the future. And we have those are some of the steps that we need to take to get there. Actually brings me to the end, a little early. If you have any questions at the end of this talk, please reach out. That's my email and Slack handle and some of the Open edX related Slack channels I'm a part of. And that leaves us a lot of time for questions. Thank you.
Okay, so any questions? And I'll run the mic out to you. Oh, come on, some questions. I have questions, but really? Oh, yes.
So we have a Django app for the LTI consumer. So I will have to log into this Django app to access the configuration. It is not in the LMS Django configuration, the Django admin.
If you install the XBlock LTI consumer library, you will install the model into your Django application, and you can manage the models from there.
Okay, so it's included in the Django admin in the LMS.
Yes.
Okay, but the Django admin is for the whole platform. Does it allow me to configure multiple LTI providers?
Well, if you have a separate separate service with those Django apps in there, that's what I was referring to. So we'll have a separate proctoring service that has the exams Django app and can configure through that admin. But are you talking about a separate Django app in the LMS?
Because we may have multiple LTI providers. For example, we can use Zoom,
Right.
typical use, Zoom or H5P as
Yep.
LTI providers.
Yes.
So will I be I have to set up them in the Django application, and then in the XBlock, I make a reference to the Django application. I don't know how it works.
I think the whole idea is not to use it at the XBlock level. So you can still use an XBlock to configure an LTI integration. I don't think I'm understanding the question.
But I need the LTI consumer to show the experience of the tool in an XBlock. Or
yeah,
not.
It's capable of doing that. Yes.
Okay.
You do it through the XBlock.
Okay.
There's been no change to that.
Anybody else? Any hands? Okay, I will ask a question. How does this affect, if we go in the mode where the XBlock doesn't have to specify things, if things are more like centrally specified and there's some kind of like simple reference to it, how does that affect like exports and imports, particularly across instances? Like what configuration goes with the export? What configuration would be like stuck in the instance?
Yeah, that's a good question. My understanding is that LTI 1.3 import-export doesn't really work very well, because even if you were to export the configuration, when you import it, represents a different LTI integration, and the client ID has changed, so it breaks. I don't know the answer to that question. I don't think we've addressed the import-export part.
Okay.